All right, a few things. First, we're going to go over Chapter 3 right now. Second, I have graded your tests for the Bootstrap one, and they are recorded in there. I will give those out to you a little bit later today. And then finally, when we get done today, I'm going to give you kind of a schedule over what we're going to be doing the rest of this week and all of next week, just so you've got an idea. And what I'm looking at right now, just because of the fact that we're actually, I don't know if you'd consider us to be ahead of time or what, but if we can get through Chapter 7 by next week, and I think we can, then there's a very good chance I might make all the next week lab, the entire week. We'll see how it works right now. All right, I want to give you plenty of time because, especially if you've never done any programming before, it's a new way of doing things. And again, it's called a language for a reason. All right, you're learning a new language. So with that said, let's start on Chapter 3. I'm on page 95. It says, in the last chapter, you were introduced to the basics of JavaScript coding. Now you'll learn how to code the JavaScript statements that drive the logic of an application. So what I'm going to do, very similar to what I did yesterday, is we're going to go over the stuff that's in here, all right? And as we do, we'll just write some kind of a simple program or programs as we go, just so you can see what's going on. So the first thing that we'll talk about are relational operators. Then we'll talk about the logical operators. Then, even though it says in here if, while, do while, and for, I don't remember if it's in this chapter or not, but I'm going to introduce the switch statement to you as well, just so you see what it looks like. Then they've got 3 illustrative applications, the MPG one again, the enhanced test scores one again, and for whatever reason, it appears as though the people who work at Muroc are kind of infatuated with future value programs, because virtually every book I've ever seen of theirs has got a future value program in it in one form or another. All right. And we will talk about arrays. And again, it's an introduction to arrays. So if they don't totally make sense, I wouldn't let it super throw you. Plus, I'm going to explain it a little bit differently than they do in the book. All right. In fact, for you two, you may have heard me give this kind of explanation before. I don't know. And then we'll go back and relook at the test scores application utilizing an array. All right. So kind of like we did yesterday, and you can do this. You can, if you want to, you can not do it. I mean, whatever you feel like doing, but kind of like we did yesterday, I'm going to come in here as soon as I close all this stuff because I got 10,000 things open. All right. I've got this JS practice that I created yesterday, if you remember that. All right. So I'm going to open this up, and I'm going to very quickly look at this scripts file. And you know what? There's nothing I need in there. So I'm just going to get rid of everything that's in there, and I'm going to start adding stuff to it. Does that make sense? All right. And the other one that was in there was this index file, which I think didn't do anything. I don't need this script thing in here anymore. So I'm going to get rid of that. And I'm calling, so I'm going to call this JavaScript practice 2, okay? And I'm still going to call the scripts.js file as we go on. All right. So as it says, conditional expressions are expressions that evaluate to either true or false. We've talked about this before. When you say if, and that's what we're going to do, and you put something in parentheses, that's a conditional statement. Whatever if this has to be either true or false. I remember reading an article quite a few years ago. It was like, a computer doesn't understand kind of pregnant. You're pregnant or you're not pregnant. You're married or you're not married, etc. All right, it's one or the other. So as it says, you use these expressions in if statements. You also use them in while loops, for loops, do while loops, really any version of the for loop, and we'll look at a couple extra ones today. Now, the first thing they talk about in here are these 6 relational operators. I'm not going to, well, yes, I am. Don't use first 2. Don't use the double equals. Don't use the exclamation point equals. Instead, use a triple equals and an exclamation point double equals. I'm going to show you why right now. All right. So I'm going to come in here and I'm going to go into my code, into my code in VS Code. All right. And not that one, but I want to open up the same one that we had yesterday. So I'm going to open this up with code. All right. So again, you can see there's really nothing in here of any consequence, and this is empty. All right. But I want you to see a couple things. So I'm going to come in here and I'm going to say let variable, so var1 equal 27. There's no significance to that number, just so you know. And I'm going to say let var2 equal double quote 27, double quote, like that. And I'm going to say if var1 equal var2, so if they're equal, and I'm going to explain all this, so don't let it throw you if you don't get it, okay? So I'm going to say alert, the two values are equal. All right? Else, alert, the two values are not equal. So what I'm concerned with right here, even if you're typing, just stop for a second and look up here. I'm creating two variables. One has got the number 27 in it. That should be obvious to you. The second one, that is not the number 27. That is the string 27. Just like the address of this building is 751. That's what we typically say. 751 Part01. We don't say 7, 5, 1, but technically the second one has no arithmetic value whatsoever. Do you understand that? It's a string. That said, I'm going to save this. I'm going to go back and I'm going to save this. And don't worry, I'll go back to the program in just a second. And I'm going to open it with Live Server. And notice what it says. The two values are equal. All right? That's why you don't use a double equal. Now, because all it says is, for lack of better words, do these two things hold the same thing? Not the variable type. Do they hold the same thing? But notice if I go back and I'm going to copy all this, and I'm going to drop it right below, but I'm going to change that to a triple equals. All right? So here it was a double equals. Here it is a triple equals. I'm going to save this. I'm going to come back and run this again. And it says the two values are equal. That's the double equals. The two values are not equal. That's the triple equals. So let's talk about what the difference is between these. Well, one has 3 equal signs and one has 2. Yeah, I get that. The first one is a test for equality. The second one is a test for equality and identity. So this one says, not only do they hold the same value, but are they the same type of variable? This just says, do they hold the same value? All right. I would recommend very rarely, if ever, and probably never using double equals and never using the exclamation point equals. Instead, use the triple equals or the exclamation point double equals. All right. Now, a lot of times if you just use the double one, it'll still work. It depends on what you're trying to do. All right. So if you look up on the screen here, I'm going to change this, but just look. If I did this, if I said here 27 right there, okay, that would work whether I used a single equal or a double equal. But if you're comparing two things where there is a chance that one of the things could be a different data type, always use the triple equal. All right? I mean, I can't say it too many times. All right, so that's a start. the other ones, am I right in assuming with these here, greater than, less than, greater than or equal to, and less than or equal to? Am I right in assuming that probably in junior high math, you learned about that stuff? 7 is greater than 6. 7 is also greater than or equal to 6. 6 is less than 7. 6 is less than or equal to 7, etc. All right. I mean, I don't mean to insult anyone's intelligence, but I'm just taking for granted that we don't have to spend a lot of time on that. All right. So a conditional expression uses the relational operators to compare the results of two expressions. It returns a Boolean. So again, when it makes that comparison is true or that comparison is false. All right. It says it's very hard to make that on floating points. All right. You may or may not be aware of this, but floating point, we talked a little bit about this yesterday. Floating point values are stored differently internally, typically in different types of machines. All right. So it says because floating points aren't exact values, you shouldn't use the double equal or this one, all right, to compare them. Now, we looked yesterday at NaN. There's another thing called is NaN. All right. So what if I went back and changed this? So I'll go back to the program we're writing. And what I'll do is I'll just grab all of this just so it's still there, and I'll comment it out. All right. But I'm going to come back and change these like this. So I'm going to come in here and I'm going to say, let var1 equal parse int prompt enter a number now. Now, if you look on the screen here, if I put this in here, comma, and I put in, for example, 44, that is giving it a value. So if I hit enter, it'll put 44 in there. If I leave it blank, there just won't be anything in the box. All right. So I'm going to put that one in there, and I'm going to do it like this. And then I'm going to copy this. And I'm going to say, enter another number now. All right. And we'll make this 55. All right. So that's what we've got in here right now. Okay. Now, not doing anything with it yet. Not doing anything with it. So let me get off of here. I'll come right back. I just want to show you that if I run this now, notice, please enter a number now, and it's got 44 in there. So if I hit enter, that's now got 44. If I hit enter again, that one's got 55. That should make sense to you. All right. But what I can do, and I want to show you one of the reasons you need to use loops. I haven't talked about loops yet. We're going to talk about them in just a minute. But I want to show you one of the reasons now why you want to use loops when you write programs like this. So if I come through here, I could do this. I can say if var1, let me try that again. If is NaN var1. So that's saying if what I entered in for the first number was not numeric. Does that make sense? I'm saying if what we entered for var1 was not numeric, I left it blank, I put hello in there, it doesn't matter. I did something illegal. Well, then I'm going to ask you to do it again. All right. And I'm going to do the same exact thing in here for var2. So we are asking the user to enter a number. If they do enter a number for this, this will be false, so nothing's going to happen. Does that make sense? If they enter a numeric value for this, nothing's going to happen here. So I'm going to come out and I'm just going to do an alert. And I'm going to say var1. In fact, let's use our template literal so we get used to using those. So I'm going to say var1 equals var1 and var2 equals var2. All right, so let's assume I'm going to do this first. I'm just going to hit enter for both of these. Are you with me? So for the first one, it should give me 44. For the second one, it should give me 55, correct? So the alert should say var1 equals 44 and var2 equal 55. Would everybody agree with that? All right, let me save this. I'll come right back to the program. But let me run it and see if indeed that's the case. So there's var1, there's var2. var1 equals 44 and var2 equals 55. Just what we thought would happen. All right, so I'm going to run it again. Just by refreshing my screen. And this time, I'm going to put in 66 and 99, just numbers. And it says var1 is 66, var2 is 99. So that worked. All right, now I'm going to run it one more time. And I'm going to leave it blank. And leave that blank. So, like it should, it says enter a number now. And guess what? I'm going to leave it blank again. And now it says enter a number now. All right, whoops, I did it too fast. I'm sorry, I hit enter too many times. So nothing, 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 nothing. So it says var1 equals NaN, not a number. var2 equals NaN, not a number. Does that make sense? Because when you look at this, I'm assuming I call an if statement a one-time shot. So if somebody screws up and you ask them to fix it, they got one chance to fix it. That's it. Now, I'm jumping ahead a little bit, but I want to show you something. I'm going to change the word if right here. I'm going to change it to the word while. And just so we can differentiate, I'm going to say enter number 1 now. And here I'll say enter number 2 now. Okay? All right. So I've changed the if statement to a while statement. All right? And I changed just with the writing we had here and here, just so it was a little easier for you to see which one we were doing. All right, so I'm going to save this. I'll come right back to the program in a minute, but now notice what happens. All right, so I'm going to leave it blank. And I'm going to leave it blank again. And I'm going to leave it blank again. And blank again. And blank again. See that? I'm stuck in here now until I put in something numeric. Now, I'm not checking to see if it's positive, negative, etc. So I'll just put in here 12. Now I'm in, what didn't it like? 12? Oh, it still doesn't like it. So hold on. Running it too many times here, but that still should have worked. So let's look. So while it's not numeric, we're telling it to do it again. Oh, that would have been kind of nice to say var1 equals parse int and var2 equals parse int. I wasn't setting it equal to anything. All right. So let's go back and let's run it again. So again, I'll just leave this blank and I'll leave this blank. Now it's telling me to enter something for var1, and it still is. So if I put in something non-numeric, but if I put in 12, now it says number 2. And again, while I leave it blank, or I put in non-numeric, etc., it takes that, but as soon as I put in that, okay, so you can see, hopefully, the difference. When we did it this way, and we had an if here and an if here, it's a one-time shot. We are assuming that the person is bright enough that if we let them, we could have given them a message here too, correct? We could have said, hey, must be numeric. Enter number 1 now. We could have said the same thing here. Must be numeric. And enter number 2. Now you can say that till you're blue in the face. But if the person running the program either doesn't care, doesn't pay attention, maybe is that dumb, or wants to see what happens, whatever. All right. So let's go back to what we had originally. So I'm going to take these, and for now, I'm just going to comment them out because I moved ahead a little bit. All right. And I'm going to uncomment these. This will still work. All right. And in fact, let's use the triple equal because it's better. If I do put in the same number for both, this should still hit, correct? If I put in 44 for each, all right? Yeah. Now, we could have done the let here and put the while right underneath, then the var2, and then the while. There's a lot of different ways you can write this stuff, is what I want to tell you. All right. So, and again, we could have come in here and said if var1 is greater than or equal to or less than or equal to, etc. We could have done all of that stuff if indeed we wanted to. There's absolutely nothing wrong with doing that. What I'm trying to get across to you, though, here, and maybe I'm not doing it that well, I don't know, but you should at least have an understanding that the conditional expression is what is in the parentheses, and the relational operators are triple equals, double equals, exclamation point equal equal, exclamation point equal, less than or equal to, greater than or equal to. And if you get that, there's nothing more to get. All right. Now, one thing that we did not take a quick look at was this. We came in here and looking back at the program again. All right. We did have an else in here, so I guess I did put it in. So what I want you to understand is when this program runs, either line 15 must execute or line 18 must execute. Only one can execute, but one must execute. If we put in two numbers that are the same, number 15 will execute. If we put in two numbers that are different, line 18 will execute. Does that make sense? All right. What if we didn't want to allow negative numbers, or we didn't want to compare negative numbers? So then we could come in here and we could say something like this. I'm just trying to introduce a few things to you here. We could say if var1 is less than 0, or, and again, we'll go over all this in just a second, or var2 is less than 0, what does that mean? I'll put in here alert, we don't compare no stinking negative numbers. All right, kind of stupid, but just so you get the idea. So, look on the screen, please. These inner parentheses here, those here and those here are not mandatory. You could have just had the out things of parentheses. I know that a student years ago, now it's got a bad connotation, but this was many years ago, used to refer to me as the parenthesis fairy. Because they said, but you use parentheses all over the place. And I said, yeah, because I want to leave no doubt. If the program is screwed up, I want it to be screwed up because I did something wrong, not because somehow the computer screwed up. Because even if the computer screws up, you can already guess this, who the hell are they going to blame? It's my fault anyway. Then I should have known better. All right? So now I've got this. So I can come in here and say, else if var1 equal var2, then alert the two values are equal, And then otherwise, we'll say they are not equal. So if you look up on the screen now, what we're saying is either line 15 or line 18 or line 21 have to be, one of those three lines has to be hit. Only one can be hit. If it finds a match right here, look on the screen, please. If it finds a match right here, it skips the rest. If this isn't true and it finds a match here, it skips the last one. If this is false and this is false, since this is just an else, there's no check made there. That one has to run. You can have as many else ifs as you want to or need to have. Did you hear that? So you can have an if. If you've got an if and it has no else ifs and it has no else, if the if is true, you do it. Otherwise, you do nothing. If you've got an if with an else, if the if is true, you do what's underneath that. Otherwise, you do what's under the else. All right? Now, it's not mandatory that you put a final else in there. Most of the time, people do because it's a catch-all. Does that make sense? All right. Now, I'm not going to run this. I can. But if I put in one or more negative numbers here, I'm going to get that, correct? Otherwise, if I leave them at 44 and 55, that's going to run. If I change them both to 55, that's going to run. Does that make sense? Yes? Any questions on that? All right. Let's look at one more similar example, okay? I'm going to come in with a new variable in here. And I'm going to say, let size equal, and I'm not going to do a parse int. I'm just going to do a prompt. So I'm going to do a prompt here, and I'm going to say, enter your size, and then we'll put small, medium, large, or extra large. Now, I'm asking you this question. Does that make sense to everyone, what's going to come up here? And let's say we suppose that most people, I don't know, most people are mediums. I don't know if they are. Wish I was a medium. All right, something like that. So let's see, what did I goof up here? That. And something's still goofed up. Enter your size. There we go. So when I run this in a minute, it should say, enter your size, and then in parentheses, S, M, L, or XL. And in the box that comes in underneath it, it'll say M for medium. Make sense? All right. So I'm going to comment this out right here. And I'm just going to write the code right underneath it. In fact, we don't need this one right now, and we don't need this one right now. All right? So I'm going to do this. I'm going to say if size equal S, alert, you are a size small. Hopefully you can already figure out what's going to happen here. Else if, let me just grab all this. If we put in a medium, you are size medium. All right. And then we'll have another else if. And if it's an L, you are a size large. Oops. Try it again. Come on. Large. And then another else if your size that you put in was an XL, you are size extra large. And we'll even put a final else in there. So else, alert, your size is unknown. Now, you may or may not have realized it, but there's a couple problems with this. All right, what do I mean? Well, first of all, what if I put in a lowercase s? Guess what? It's not going to match. So I could have come in here and said if size equals an uppercase S or a lowercase s, I could have done that. Are you with me? I could have done that. And it would work just fine. Now, I'm going to try something I have not tried before, but I have no reason to think it won't work. I'm going to do this prompt, and after you do it, I don't know if it'll take this or not, but I'm going to try to put a dot to uppercase. Can you figure out by looking at that what that's going to do? It's going to take whatever value we put in there, and it's going to convert it. So if I put in a little s, it's going to convert it to a capital S. Now, it may not work. I've never tried doing it like that before, so it may not work. And if it doesn't, then down on the next line, I'll just say size equals size dot to uppercase. All right, but let's see if this works. So I'm going to save this, go back to here, open it with live server. So it says my size, I'll leave it as an M. You are a size medium. It appears to have worked. Let's run it one more time, and I'll put in here a little s. See that? A little s. You are a size small. So it does take that. All right, I'm going to run it one more time, and I'm going to put in here a G. There is no G. So your size is unknown. So it all appears to work. Now, a couple things about this. First thing, if you're writing this and you're writing this for someone, all right, you should at a minimum be testing S, M, L, and XL, both in upper and lower and mixed case. Does that make sense? All right. Okay. Now, here's another problem with this. I'm going to run it again. What if somebody says, oh, yeah, I'm a small, says your size is unknown. All right. What's the problem? The problem is it's just checking for an S. Does that make sense? All right. So I'm already, believe it or not, I'm going ahead here and I'm showing you some stuff that's a little bit more complex because it makes sense in this context. So I'm going to say, what if I did this? What if I let just S for that? What if I set that equal to size dot char at 0. And then I'm going to have to change all these to S. Should have probably just made the first one S and then made this size, but it's okay. All right. What line 4 does is it just grabs the first character. All right. In computers, much of the work that we do will start at 0 rather than 1. These guys have heard this probably already, but that's an old computer joke. All right, there's two computer jokes. One is, how many computer programmers does it take to change a light bulb? The answer is none. That's a hardware problem. Okay. And the other one is, ask a programmer to count to 10, and they say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because they start with 0 with almost everything that they do. All right. So now, having it run like this, let's go back and run this. And unless I screwed up, but I'm going to put in here small, all in lowercase. And it doesn't like something. That's okay. So let's inspect. Type error. Size.char at is not a function. Okay. Okay, so I used the wrong syntax there. Oh, because I wrote chart at instead of char at. Maybe you caught that. I don't know. It's char for character. So char at. Let's see if that fixed it. I have no idea if it did or not, and I'm going to get rid of my mail in just a second. So I'll put in here extra. Well, that's we're going to have a problem with extra large, aren't we? Because that's XL. So I'll put in here large. Here's is a size large. All right. So, like I said, this is going to be problematic for this one. Because it's only going to find the X. We could just check for that All right, but we're checking here for an XL. So we could come in here and just check that for an X. That's one way around that. I don't know, that's not a great way, but we could do that. All right, but what I'm more concerned with is, do you understand what's happening in this line? We are asking the user to put something in to that prompt box. Then we are automatically converting it regardless of what they put in there. If it's a number, you can't convert a number to uppercase. That doesn't make any sense. All right? But if it's any kind of letter or word, it'll now be all uppercase. Then we are plucking off just the first character from what we just converted to uppercase. All right? Now, we may, I'm not going to, I don't know if this would work or not, but we may even be able to do to uppercase dot char at 0. That probably would work. That's called chaining, when you start putting dot this, etc. All right, the problem with doing it that way is now it's size. See that? Then I got to change all these back again. I can do that. Some people like to chain as much stuff together. Other people like to break it up, even though it takes a little bit longer to execute because it's multiple instructions, but to them it makes more sense. I would say that's what you should be shooting for right now. These guys, again, have probably heard me say this, but in the first year that you're here, you should be programming for understandability. Everything you do should make sense to you. It shouldn't be, well, guess what, Jeff? I took this 37 lines of code and I knocked it down to 30. I don't have a frickin' clue what it does now, but it's 7 less lines. Well, then what have you accomplished? You've confused yourself. All right. Okay, so you all see this. Now, I want to take this and I'm going to comment it out right now. Why? Because I want to show you another way to write this. All right, bless you. This is not in the chapter, but it's close enough that I'd like to show it to you. Bless you. So I'm going to type in here switch on S. And put it inside of curly braces. And then I'll say case S. I'm going to steal all these alerts. In fact, let me just do this because it'll work a lot faster that way. Small, medium, large, extra large, default. Okay. One thing I hate is it screws up with my tabbing here. All right. So that's a small. This will be M. So this will be a medium. This will be an L. So it'll be a large. This will be an, we're just going to say X like we did before, for extra large. And this one, you use the word default. Let me move this over. All right, so this is default. And size unknown. So what I'm telling you is this is going to run the same way. This is what's called a switch statement right here. All right, I'm going to leave those lines in there, those blank lines, because I think it reads a little nicer. But it's like writing that if that we just saw. We're saying switch on S. So that S is this S right here. If it happens to be an S capitalized, we put the alert, you're a small. Then notice the word break. Break means get the hell out of this switch statement. If you don't put in the break, if you don't put it in, it's going to keep going down. So if I put an S in there and I leave all those breaks off, it'll say you are a size small, you are a size medium, you are a size large, you are a size extra large, unknown size. The only time I don't have to put one in technically is here because it's at the bottom anyway. If you use a default, it's like using that final else statement. It's got to go at the bottom. If you don't put it at the bottom, it's going to get hit right away. That doesn't make a whole heck of a lot of sense. So I'm telling you, that right there is the same as what you saw below with a series of if statements. Now, sometimes it's easier to do it this way. All right? So let's pretend for a second. All right, does everybody who wants this, does everybody have it? All right, so I'm going to get rid of all of it. Why? I'm going to show you this. I'm going to say here, let grade equal, and I'm going to put a prompt in here, a parse int with a prompt, enter test grade, and we'll say it's got to be between 0 and 100. All right? And we'll give it a default value of, I don't know, 77. All right? Does that make sense? And we're going to suppose 90 and up is an A, 80 to 89 is a B, 70 to 79 is a C, 60 to 69 is a D, and below 60 is an F. Does that make sense to everyone? All right? So I'm going to write this very quickly. I'm going to say if, well, first thing I probably should check for is non-numeric grade, right? Okay, so I can do this. How about if I do this, though? How about if I say if is NaN, oops, let me turn that off. That won't make any noise, though. So if is not a number, grade, and I'm going to put this whole thing in parentheses. You'll see why in a minute. All right. Or, which is two pipe signs, or grade is less than 0, or grade is greater than 100. So if any of those things happen, that's illegal, for lack of better words. What do we got here? 1, 2, 1, 2, 1, 1, 1, 1. Why doesn't it like that? It's telling me, am I still missing one? Expression expected. One, two, 1, 2, 1, 2. Oh, I'm not sure what it doesn't like here. No. All right. If is NaN grade, so that all goes together. All right, so if it's not numeric, or if the grade is less than 0, or if the grade is greater than 100. All right, so I think it's probably because I didn't put this here. That's right. So if that's the case, it's illegal. Would you agree with that? All right, well, remember, if I use this as an if, I can just put in another bad grade. But if I make this a while, now it's stuck in there. Does that make sense? All right. So I'm just going to take what's in here, and I'm going to copy it down here. So now I should, by the time I get out of here, have a value that's numeric and between 0 and 100. Would you all agree with that? And nobody said this. Everything we've done so far is totally fine. But remember this from yesterday? Const min grade equals 0. Const max grade equal 100. Remember that from yesterday? And we talked a little bit about constants. Well, now we could come in here and say if it's less than the min grade, or it's greater than the max grade. Oops, if I can spell. Okay, now why is that important? What if I'm a teacher and sometimes what I'm working on is worth 100, but sometimes it's maybe just a test of part of a unit. I want to make it worth 50. Then all I have to do is change it here. And what if I say, even if you show up, you get 10 points, even if you don't do a flipping thing? So then I could change this if I wanted to. All right. So when I get down to here, now I can come down and say if grade is greater than or equal to 90, and we'll make another variable here. We'll call it letter grade. LG for letter grade. I'm just going to set it equal to nothing. So if the grade is greater than or equal to 90, the letter grade is equal to an A. Again, you can use double quotes there, or you can use single quotes there. Doesn't matter. So, else if grade is greater than or equal to 80, and I'm going to say LG equal B. I should just be consistent and just use single quotes or just use double quotes all the time, so I'm going to try. All right, so it's a B. Otherwise, or else if it's greater than or equal to 70. What I did there, but I did something. There we go. Letter grade is a C. Otherwise, if it's greater than or equal to 60, the letter grade's a D. Else, the letter grade is equal to an F. All right, take a look at that after you've done typing it in, if you want to do so, and tell me whether or not there's anything in there that doesn't make sense to you. And I'll tell you the question that I typically get asked about this. And they're like, wait a minute, let's say the person gets 100. Yeah, it's greater than 90, but it's also greater than 80, and it's greater than 70, and it's greater than 60. But remember, as soon as it finds a match, it does that line and it skips the rest. So if I say that you got a 93 that's greater than or equal to 90, it'll set the letter grade equal to an A, and it'll skip all of these. If I say you've got an 83, that's false, but this is true. So it'll do this, and it'll skip all of these. Same thing going down 73, 63, etc. So if I come in here now, and at the end, I'm just going to do an alert, and I'll use the template literals, and I'll say number grade, and I think we call that one grade, and letter grade, consistent, Jeff. All right. So now if I come in here, I'm going to run this a couple times. All right. So if I come in here, okay, enter test grade. Let's just go through the whole gamut here. So how about 1,000? How about 101? It just asks us to do it again because that was an unacceptable value. How about -2? Again, it asks us to do it again. But if I come through here and I write 93, all right, number grade 93, letter grade A, good. And I do it again, and I put in 83. 83, and it's a B, run it again. 73, that's a C, run it again. 63, and it's a D, run it again. With 53, and it's an F. All right? So hopefully going through that, this made enough sense to you that you can work your way through it. Now, I'm going to show you one more thing. Don't type this in because it's stupid. If I wanted to do this as one of those switch statements, I'd have to do this. So I said, don't write this, but I have to say switch on grade. And then I'd have to say case 100, case 99, and I'd have to go all the way down. Yeah, I know. And I'd have to say 98, and I'd have to say 97. You get the idea? So I'd have to basically do 101 of those, 0 to 100. So you don't do that. So when you're working with ranges, you use the if statement. All right? Now, another thing that's in here that I want to mention to you about this, all right, this is the or. That means if any of those things are the case, you do this. All right? So it's like, if the opposite of or basically is and, when everything has to be true. With an and, it's 2 ampersands. Now, this is never going to be true because what we enter for grade can't both be not numeric and less than 0 and greater than 100. There's nothing like that exists. But if I've got multiple conditions and I want every one of those multiple conditions to be true, all right, if I do, I use an and. If I want somewhere or any of those conditions to be true, I use an or. And the other one that's in there is what's called a not, an NOT. A not is an inverter. Not true means false. Not false means true. And to make it even a little bit more difficult, you can combine ors and ands and nots into a really frigging big condition. You can do that with no problem. When you do that, you do nots first. That's the most restrictive. Then you do and, then you do or. Anybody want to guess if I don't want to do it that way? What do I have to put around the condition? Parentheses. But otherwise you do nots, then you do ands, then you do ors. Okay? All right. We'll go for about 5 more minutes. We'll take a break. All right. Yeah, if you do this, in most programming languages, if I say if x equals 6, doesn't matter what x is. As long as it's numeric variable, that's always true. All that means is, can I literally take 6 and assign it to x? All right. In an if statement or in a loop, you never, ever, ever use a single equal. And as I've told you, you really shouldn't use the double equal. You should be using the triple equal for equality and the exclamation point equal equal for inequality. All right. So I've already shown you these logical operators. Okay. So you've already seen these. And again, you do nots first, then you do ands, and then you do ors. And let me just give you a quick little thing of terminology, because I've been asked this before. Why do you do nots first? Because a not is what's called a unary operator. It only operates on one thing. An and an or are binary operators. They operate on 2 things. And is more restrictive than or is. That's why you do ands before you do ors. Now, one thing about this, just so you know, this language, like most programming languages, uses something that's called short circuiting. What does that mean? That means this is an or. So it tests this. If I put in something that's non-numeric, it doesn't test the other 2 things because it doesn't have to. Remember, it's an or, so if it's not numeric, if that's true, why even test the other ones? Because it doesn't matter. So the short circuiting says it only tests as far as it needs to until it finds something, so if these were ands, it would have to check the first two. It would have to check, okay, and actually technically it wouldn't. Because if that was false, it wouldn't matter if that was true or not. And we can get into a whole thing. Back when I was going on for my master's degree, it was in software, but I took 2 hardware classes. And we literally had the old-fashioned Heath kits where you had to wire stuff up. All right? And the thing is, what you found out was if something was an and, basically, and everything met, it would light up. That was good. If something was an and one thing wasn't true, it wouldn't light up. With ors, only one has to be true. With ands, they all have to be true. So you can even look this up if you want to. We used to go over things like truth tables, which said if this is true and that's true, it's always true. All right, if it's an and. Otherwise, it's always false. If it's an or, if this one is true or this one is true, it's always true. Only if that's false and that's false is an or false. All right? So again, not and or. All right? And there was the short circuiting. All right. Now, I'm going to run through this very quickly because you've already seen it. How to code the basic if. We already looked at that. All right? I gave it to you in here. Now look at, this is one people use all the time. You ask for an age. If the age is greater than or equal to 18, you may vote. Otherwise, you're not old enough to vote. All right? And again, you can use else ifs. We've already seen that. You can use an or an and in here. We've already seen that. This should be a triple equals. So should this. So should this. So an if statement always has one if clause. All right. It can also have one or more else if clauses. And if it has an else, the else must be at the end. We've already looked at this. You can have an if within an if. That's called a nested if. You can have an if within an else if, or an if within an else. All right? All right, so this is a good place to stop. So when we come back from the break, it's 9:04. Let's come back at 9:20, and we'll talk, and we'll look at how to write the numbers from 1 to 10 using 3 different loops. All right?